recording. Okay, today is August 28th, 2019. It is, well, it just clicked over 11 o'clock, and as I promised, I will start on time. Let's see, a couple little housekeeping details. I have updated the syllabus and put the correct dates in there. Notice that, let's see, the next one that's coming up is the date, the census date. So you have to make sure that you have done something. Flunked a quiz is fine. That's something. I was going to put a quiz in there saying, you know, what is your name? But you don't have to get it. You don't even have to get it right. But you just have to turn in something for me. So that's kind of why I put those things in the first one. I'm not worried about the due date. The due date is they got to be in by the census date. So that means I have to have something that I can look at and say, aha, yes, this person is actually here doing and present. Otherwise, the registrar drops you. Other than I don't drop you, the registrar does. Let's see, what else? I have made a couple of changes to that first Dropbox practice. I changed what you're submitting to make it a little bit more like what we're doing. But if you've already submitted it, don't bother changing it. That's about it. So we'll move on today into the third module, which is really the first of the modules. I'm thinking about making a change to our the way I'm going to schedule the class. I'm thinking about changing that to doing a 2-hour lecture on Wednesday and having a 2-hour lab on Monday, where with the 2-hour lab, I would do that online. So I would be logged in, and all you have to do to talk to me, you don't have to make an appointment, but you just log in. You can do it from home. You can do it anytime. You log in, and I'll be there. I'll even have my camera on because I'll be using my own computer. And so you'll be able to get help on any of the labs. I'll be able. You can share your screen with me, and we'll talk about how you do that. You could do it from the open lab. Thoughts, feedback on that? I mean that, you know, even if you're in the face-to-face class, you would still get the same amount of time in lecture, same amount of time in lab, whether you'd be sitting here or not. But you could sit down at any computer, log into Zoom, connect to my my Zoom, and I'd be right there, looking over your shoulder. Well, not unless you let me look over your shoulder. But if you shared your screen, I could see exactly what you were doing. I think that'll work. And the nice thing about that would cut down on some of our commuting time. In terms of, I don't know about you guys, but for me, it's a long drive to get in here. On Wednesdays, I'm here the rest of the day anyway, so I'd be available to meet with you after class. Like today, I'm here until 6 o'clock. I'm here. I've got a class at 6 o'clock. Anyway, just a thought. I'll be asking you more about that. Anybody online have any comments? Online students usually don't care one way or the other. Okay. So we'd have the same amount of class time. We just schedule it differently. The way I'm thinking, we would not use the classroom on Monday. You could use the open lab. Would that, everybody's got to be on board with it. If you're not, then we won't do it. Okay. You would need to be able to use Zoom, but if you can use Zoom effectively, it's a very good tool, because you see me right there, and I can actually see your screen if you share it with me. What do you think?
I just want to know if the open lab will be we have to have like a headset.
Yeah, you would need a headset. Mhm. We'll talk more about it. That you'd have. I'd be available after class, certainly on Wednesdays, if um, and so you'd have that full time. Okay, couple of things. Let's see. Okay, here we go. I'm going to start. Probably the first thing I need to do is check and make sure that my SQL Server is running. So I'm going to go to the Windows Admin Tools, or maybe I have and I'm going to go to my services. And I'm going to check and make sure that it's running SQL Server. QRS, SQL Server. Okay, so I see that mine is running. And if yours is not running, make it running. Double click it and make it run. Oh, thank you. Somebody's also responsible for telling me to turn on my my screens. Sitting here talking, the people at home can see what I'm doing. Do we have any light there coming up there? Okay, that one's coming. Okay, they'll come up in a minute. So we'll turn on our. How you doing? So start our SQL Server. And we're done with that once he's started. And let's see, we're going to go to our start menu, and we want to find SQL Server Tools 18. And then that will be the Microsoft SQL Server Management Studio. Let's see, were you here for last? Okay. I'll need to there's some instructions on there on how to install. Will you be using your computer, your personal, or these?
I'll be using personal.
Okay, there's instructions on Canvas on how to load. It's actually, there's 2 different recordings on how to load up SQL Server, but we'll get one here working for you. Okay. One other thing, we do not have class on Monday. Okay, here we are. I'm going to log in with what? I didn't know we even had speakers on them. We're going to log in with SQL Server authentication. SQL Server is your username. My username is SW Smith, and your password. And I usually check remember password. It's up to you. I wouldn't do that on a production system, and we'll get yours installed. Questions? Okay. Let's see, I guess I see my icon is bouncing and I don't see, do I see a chat? Okay, somebody says they like that idea. People online typically don't care one way or the other how we schedule the face-to-face sections. We're talking about making some changes in the times on the face-to-face. But everybody's got to get along with it. Okay, first thing I want to do is show you guys how to turn on your line numbers. That's usually a big one. And so I'm going to go new query initially, and that will just bring up the query window. And as I type, notice I don't have any line numbers. So when you have errors, not if, but when you have errors, it will say, you have an error on line number 23. Well, where the heck is line number 23? So you're counting down to get to line number 23. That doesn't help me any. So I'm going to go ahead and turn on my line numbers, make a note of how you do this. Well, I am recording this. So you go to Tools, come down to Options, very bottom. Tools, Options. Almost to the bottom of that one is Text Editor. Text Editor. Drop down the little arrow icon there. Go to All Languages. And then go to, well, General. This one is All Languages, but if you go to General, this is the general one. And notice that one of the things that you have there is line numbers. So we went to Tools, Text Editor, Tools, Options, Text Editor, All Languages, and General was the default there. If you click line numbers will come up in a minute. I usually unclick. It's up to you. Your call. In fact, line numbers are up to you for that matter. Most people like those. Some people like automatic brace completion. In other words, when you open a parentheses, does it automatically put the closed parentheses there with it? I don't like that particularly, but if you do like it, then you can leave it on. Is that printer not working? Okay. So when you say okay, now my line numbers have popped up there, and there's much rejoicing. Okay. The other thing that I wanted to do today, let's go over to, no, I don't want to save that. Let's go to, you may have this file already. I'm going to go to my modules. I'm going to go to Module 2, page 5, Module 2, page 5, not page 5, but create the accounts payable database. We have already created the database. We did that last period. We created the AP_DB. We're going to use that one now. In here on page 2, there is a link right here to create that, to the program, the code that creates that. So I want to go ahead and download this guy. So download. We'll save him. Show in folder wherever he ended up. Okay, he's in my downloads folder. That's fine. I'm going to move him to my desktop, but that's just me. That's because that's what I'm going to do. I'm going to put him in my install files. I suggest you put that create AP, create_AP. It's an SQL file. I suggest you put that on your flash drive or someplace where you can get to it, because as we go through the class, you will invariably trash your database. It happens every semester, and I'll trash mine too. It just happens. If you want to put it back like it was when it was before you got it, like however it is now, you just simply run this file again, and 5 seconds later, everything is cleaned up and put back into its original position. So this is real handy. I'm gonna go back to my SQL, and I want to open it. So I can say File, Open, File. I can do that. But the easiest way to do it is with a Control-O. And so that's usually what I use, is Control-O, gives me an open. Now it's asking me, what do you want to open? Well, where did I put it? I don't know where you put it. I know where I put mine. I don't know where you put yours. If it's on your flash drive, that's fine. What? It's fine wherever you put it, as long as you can get to it. Mine's on my desktop. If I can get to my desktop. And SQL Server. So mine is right here. Okay. I'm going to open that guy. Before we get done with this class, you're going to be able to read that code, somewhat. It's about 700 lines. Yes, I wrote it. And it creates everything. First thing it does, it goes in and drops all the tables, and then it comes back and creates all the tables, and then it populates them with stuff, and it sets up all the dates and everything in there. So the invoice dates, for example, as we proceed through the semester, the invoice dates will become stale, meaning that, there's some questions that it will ask you, find all the invoices due in the next 7 days. Well, that's 7 days from the creation date. But that's going to be 2 months down the road when we get there. So we're going to have to refresh this thing. We're going to have to come back and do this again. So basically all I have to do is I have an execute button at the top of it. See the little execute there? Bingo, we're going to hit that guy. And about 5 seconds later, we get that about 3 seconds later, it executed successfully. And do you happen to have SQL Server on your machine? Did you? Okay. We'll need to create a user and all for you. Okay. Okay, notice that it's using AP_DB. How what? I'm looking for some people saying, okay, everything's fine. Okay. Anyway, now we've got the database. So this is our working database this is one I talked about on the recording to do it. So you get that from the module. And I guess we are now ready to go. Okay. Okay, we're going to begin now in earnest, and we're going to go to the module 3 is where we start. And I talk on here about SQL. Page 2 talks about the SQL programming language. The SQL programming language is, as far as programming languages go, ancient. It is ancient. It has been around and in common use just about as it is today since around 1967 or so. It has for a programming language to last that long. The only one that even comes close to it is the C programming language, which has gone through several, reinvented itself several times. So the C programming language has just been around, and probably since around early 70s anyway. But SQL proper has been SQL and hasn't changed that much. C doesn't look anything like it did. If you look at C# today, it doesn't look anything like C. For those of you who don't know C, you don't have to worry about it. I will make some references to other programming languages, just as a show of hands or a thought. How many of you have used other programming languages? A few of you, okay. I'm assuming that's C or Java. Okay. Those of you online can chime in if you want to. I try to check Amanda. Okay, thank you, Amanda. I see you. Okay, so basically, an SQL is supposed to be a universal language of database. It is supposed to be the language that all databases understand, and by and large, it is. You can program access in SQL. It's not easy, but you can. So Oracle speaks SQL. SQL Server, of course, speaks SQL. They're all doing it, but there are various dialects of it. So while there's a kernel of the language that is the same throughout, there will be dialects that won't run. You're gonna, if you pick up a program from SQL Server and you try to port it over to Oracle, it won't necessarily run without doing some tweaking to it. I'm going to try to focus in this class on that kernel of it that is the same in all databases. So I'm going to try to focus on pure SQL as much as I can. The problem with it is that I can't. I mean, there's no such thing as a pure language. I have to do something that isn't pure SQL to get it to run on SQL Server, and then I'll have to do something different to get it to run on Oracle or MySQL or something like that. So for the most part, this class is going to be 85 to 90% pure SQL. And the rest of it, well, we'll just get over it. Introduction to SQL, describe, okay. Next. Talk about using Notepad++. If you have used Notepad++, it is a nice little text editor. I used to use it a lot more than I do now. I've kind of dropped away from it. You can look at it if you want to. It's somebody wishes to communicate with me. I do not need to take that call. Okay. So there's a Notepad. You can download Notepad++. Notepad++ is like a text editor that's just, that will handle it. It puts the syntax highlighting in it into it for any language you want. So if you want to write C code in it, you just say, okay, it's C, and it highlights the C as if it were a C editor. It's okay. I like it. This is okay. I put some stuff in here. I put some recorded lectures in here. Okay, let's talk about database. In database in general, the piece of it that represents the file, I guess, is the table. Think of a table in SQL. How many of you have some database in your background? The table is the low-level construct in a database. Think of a table as a file of index cards. Now, before I can start using my file of index cards, I go out and I get the box, and this box has lots and lots of index cards in it, millions of index cards. And so think of a database as a management system for these index cards, where we have not just, if my database only has 10 or 15,000 records, it's a very small database. A database manages millions of records, and it manages them very, very well, very efficiently. A database doesn't even hit its stride until you have 1 million records. You don't have enough friends, and you probably have lots of friends, but you don't have enough friends to put them all in a database, because you wouldn't have nearly enough. You're talking about the population of Dallas for a database, even a database like SQL Server. So what is SQL Server? SQL Server is kind of a mid-range database. SQL Server is less expensive than the Mercedes or the BMW of databases, which is Oracle, but it's more powerful than Access. So you would find database in a mid-range business. You'd find SQL Server in a doctor's office, might have SQL Server. Car dealership, particularly if they have remote dealerships out, several of them, would be somebody who would be using SQL Server. Oracle is kind of the big, the much bigger database for enterprise use. Okay. SQL Server is in more demand in this area because SQL Server is much less expensive than Oracle. Oracle implementation is thousands and thousands and thousands of dollars. A SQL Server, on the other hand, isn't that much. you're talking something in the range of $4,000 to $5,000 to get it installed and up and running, which may be a lot of money to you, but to a business buying a database, the big cost is getting somebody to administer that. Okay, let's talk about a table. In a table, there's 3 fundamental rules to a database. So a table is like a Rolodex. I hesitate to use the word Rolodex because that's a proprietary, but an index cards. Pull out one index card. The information that is on that index card is the same information is on all the cards. I don't mean the same data, but if there's a space for a name, name is on all the cards. If there's a space for an address, address is on all of the cards. So they're not different, okay? There's some things about a database that must be true before I'm gonna let you call it a database. There cannot be any duplicate cards, no duplicates, okay? And that's one of the basic rules of it. It comes from set theory. I can argue why they have it that way, but there are no duplicates. That said, that just means that there are no cards that are duplicated on all fields. If they are, they're the same card. So therefore, we can't have 2 of the same. Something has to be different. Only one field has to be different. Is there a smaller subset of that I can guarantee that is different? There is usually one field that I can guarantee that by design, this field is different. And I'm talking here about, I'm going to highlight it, a primary key. Okay. A primary key is a field, usually a field, one field. I prefer it to be one field. It doesn't have to be one field. It can be more than one. Right now, we're just going to have one field. One field that uniquely identifies at most one record. What might that be if I'm talking about employees, for example? It might be Social Security number, okay? And so for it can be anything, as long as once I say this is the primary key, I'm saying some things about it. I'm saying, number one, everybody has to have one. You cannot be an employee in my company if you don't have a Social Security number. I'm gonna get in a lot of trouble. So I have to make sure you have a Social Security number. The other thing is your Social Security number cannot be the same as anyone else's. Now, it doesn't have to be your Social Security number. I could just give you a number, 1, 2, 3, 4, 5, 6, 7, like that. And that would work just fine, as long as everybody had a number and no 2 people had the same number. I can use time. I can use your name, but your name would have to be unique, and everybody's name isn't unique. People's names duplicate. Sometimes you use telephone numbers. And that's okay, as long as if 2 people have the same telephone number, they're the same person if you set the telephone number up as the primary key, okay? So no duplicate records, and this implies the existence of a primary key. Picking the primary key is very important. What would make the best primary key for up here is an example. A person's name, well, I just said a person's name is not unique. A person's hair color is not unique either. Don't see anybody else is gray, but hey. Social Security number. Social Security number is guaranteed to be unique. By the way, we're going to run out of Social Security numbers, I would expect fairly soon in terms of geological time, certainly, and in a decade. I don't know whether we'll all be dead by global warming by then or not, but it's going to happen reasonably soon, and it's going to be a problem because I can't reuse Social Security numbers. If you give me Social Security numbers, give me the Social Security number if somebody is dead, that means I'm dead. I'm not ready yet. So we can't reuse them. A person's phone number might work as a primary key. If what I'm keeping track of is households, I can use a phone number. There's nothing wrong with that, except I can only use it once. So whatever entity I'm associating with that phone number, if that phone number is identifying an account, I can't have two of them under that same phone number. Social Security number is the best. Everyone has to have a Social Security number. So a Social Security number cannot be null. By the way, this word null means nothing. It is nothing. It doesn't mean zero. It means nothing. It gives us a lot of trouble. Nothing gives us a lot of trouble in database. We'll come back to that in a minute. A primary key cannot be null. A primary key, you must have it. Everybody must have it, and the database will enforce that. Okay. The second one, do I have them listed here? Okay, well, that's one of the first one. The second one is that data are accessed by content only. Data are accessed by content. That means in a database. I will never talk about I want the, well, this isn't true when you're going to say, and you say, hey, Dr. Smith, what about this? I'm going to say, I lied. We will never access records by say, give me the first 10 records in the table. And my nose is getting long because we do that. We're going to do that in the book, and so we're going to blatantly violate that idea. But the fact of the matter is that to be true to this model, data are accessed by content only. That means I want all of the people who live in Frisco. Show me all of the people who whose last name is Jones. Everybody from zip code 76209. Okay, so I'm talking about the content. If I'm talking about, you know, I want the third row, the fifth column, I'm in a spreadsheet. This is database. Database is by content in theory. So content only. Second rule. These are the three rules of the first normal form, by the way. And then one other one. A field has exactly one value. You say, well, how can a field have more than one value? Okay, on my index card, I might have a field and it says name. If you have a field on there, it says name, and you put the name John Doe, that is one value. It is not a first name and a last name. And you should not have it set up thus if you're going to ask for everybody whose last name is Doe. You should have first name, last name in two separate fields. You violated it if you say, I want to pull out the last names. That said, we have to do that on occasion. One of my earliest database programming assignments was for the Austin Independent School District, actually it's Eanes Independent School District, which is in Austin or near Austin, was to fix their database because they had everybody in there in their last name, comma, space, first name. So they had Doe, comma, space, John. And then they wanted to print diplomas at the end of the school year, but they didn't want that, you know, Doe, comma, space, John. They wanted it John Doe. So if you're ever going to have that problem, it is a violation to put first name, last name in there. It's okay if you have two phone numbers in a field, as long as the value of that field is both of those phone numbers. You always treat it as that is the value. That said, do we break that law? Yes, we do, very frequently. About the only one that we don't ever break is the primary key, and that is enforced. Okay, the other two, accessed by content only, and one single value. I'll point it out when we're breaking those rules. Sometimes rules are made to be broken. Not all of them are. Okay, all tables must have a primary key. Okay, let's see. I'm going to open this. Link as. Okay, I say to you, download this file, so you should go ahead and download this guy. We're going to be working with him. And I'm going to go, I'm done with this guy, by the way, Create AP. I just want to keep him around We've used him, and that's our database, and I'll be talking about these files, and we're going to talk about what's in there today. I'm going to open Control O. I want to open that file that I just downloaded. And let's take a look at it. Now, I've got two tables. And in my two tables, one of my tables is called employees. Employees. And you see employees there on line 14, where I start talking about it anyway. And then you have another table called dependents. Now let's talk about employees first. If you were setting up a index cards, and these cards you were setting them up to keep track of your employees, you have this business, what would you keep about an employee? I think we can agree on Social Security number. What else? First name, last name, birth date probably, address, salary. Okay, and we can shoe size, IQ, lots of things we can come up with there. Does an employee have a dependent? Do all employees have a dependent? How many dependents does an employee have? Without getting in trouble with the IRS. How many? Well, probably let's throw out myself. Okay, let's say I might have 0. Might I have 0 dependents? Might I have 5? We don't know how many dependents an employee has, but an employee has dependents. The way we're going to handle that is we're going to break them into two tables. Okay, and first thing I'm going to do is I'm going to create I'll go through all of this code. The first one I'll have is the employees table. Now, it is simply a create table. It's just text file, creates the table. Employees. Now, notice that I have taken this one really quick and dirty here. I'm making this one real easy. I would, boy, if I were grading this one as a working table, I would come away from it with bloody hands, because it's not nearly enough data, but it's enough just to demonstrate what I want to. The only thing I've got in there are the ESSN and E name. Now notice how I named my fields. I chose those names. I made those names up. But when I did, I put the name E, I prepended E to it. ESSN. Why did I choose E_SSN? Okay. As you look at that name, you find that name laying around someplace in a program. Ha! What does that belong to? It belongs to the table that starts with an E, probably, maybe. There's other times when it won't. But for the most part, I know where it is by looking at it. So I will use enough of the table name to make each field name be unique in my database. It is okay, but for database, to duplicate field names in other tables as long as they're not in the same table. I don't do it. And E name. Okay. Now, right after that, I have lines 24 and 25. I have constraints. What does the word constraint mean to you? A restriction. Okay, there's a restriction on this table. Constraint. This is the name of the constraint. The constraint name must be unique in the database. That means that I cannot have a constraint name that is the same name in a different table. Okay, So within ScratchDB, I can only have one constraint named employees PK. PK means primary key to me. So its name is that. And what am I saying? I'm saying that this is a primary key, that ESSN is the primary key. Does anyone know of another way to declare a primary key? Have you ever done SQL? Okay. What's your name? Liz? Okay. Sometimes people will find, anybody else know of any other way to do it? Okay, I'll show you another way, and lots of people already know this, and you'll see it. If I don't show it to you, you'll see it and you'll go, what the heck's going on? It is possible to say, put it right there and to say ESSN. I'm saying it is 9 characters. CHAR means character data. 9 characters. I'm going to talk about that in just a second. And I could say primary key right there. Now I can't say it both places. If I say it both places, I'm going to get it. Notice I got a red mark now under this constraint because I'm trying to say it twice. But that will work, but it's not as good because I haven't given it a name. It's better to give it a name. So the way I'm going to teach doing constraints is to give it a name. That's a named constraint. This one does not have a name. Okay, let me talk about CHAR. A social security number, is that really a number? Okay, that's a string of characters. Yeah, I mean, but I'm logically, as a social security number, is it really a number? Does it make any sense at all to take your social security number and add, subtract, multiply, and divide it? It doesn't make any sense to take your social security number, add it to my social security number, and subtract her social security number. What are we going to get? We're just going to get goop. So it doesn't matter. So therefore, a social security number is not a number. It is a string of characters because that's cheaper to store than a 9-digit number. It's cheaper to store characters. Other things that would be character data instead of numbers, a telephone number, a bank account number. What about a person's body weight? Would that be a number or a character string? It would be a number because it makes sense. If we were all getting onto an elevator, we'd want to add it all up and see can it handle that. So that would definitely be a number. Some things are numbers, some things are character strings. We use character strings more than anything else. If I declare a character string and I say char, C-H-A-R, and I give it a number in parentheses. Now, those of you who have programmed in C or Java are used to seeing that in square brackets. Okay, here it's in parentheses, get over it. Not a big deal. So it means the same thing. That is an array of characters, for those of you who know what that means. It means that there are 9 characters set up, and if you don't use all 9 of them, it will pad it out with spaces. So you're gonna, each one is exactly the same size in memory. And so if you just put in, 2556 into your SSN, that's fine, you can do that. But remember, it's allocated 9 characters. So if you only put in 4, you're gonna have 5 spaces on the end. But that's okay, doesn't hurt anything. Everything sorts the same way. Okay. On the other hand, you can have something like a name. A name's obviously characters. Notice that this one is called of type varchar. What do you think varchar is? Variable length character field up to 16. So I always have to give it an upper bound. Now, most of the time, if you are working in database, I'm going to be using varchar and char kind of interchangeably. I would never make a field, a varchar field, that was 16 characters. Why not? Yeah, but if it's a small field, I'm going to go ahead and make it char and just use 16 characters. If I'm only got 16 characters, I'm going to pay more for having it expand and contract. That expansion and contraction of it comes at a cost. Okay. If I just say it's 16 characters, everybody is 16 character name, that's cheaper than allowing it to expand and contract. On the other hand, if I had, if you might have a really, really long name, let's say 1,024 characters, and some people had 500 characters, and some people only had 3, and some had the full 1,024, I would do better with varchar. Let them grow and shrink.
So when it comes to data storage, doing this standard car or char would end up storing more data.
The question was, when it comes to storage, which one of them would be more efficient? The efficiency would be in terms of, this one is more efficient in terms of the disk use, and particularly if they're about 9 characters, because I'll just go ahead and eat that extra space, or 2 or 3 or 9, well, yeah, 8. As opposed to having to go through the extra work of making it expand or contract to go down to 8 characters. I'm never going to reclaim the cost of that one character that it costs if I'm expanding and contracting. So the question is, when would I? It's just kind of, you got to know your database. I usually think my rule of thumb is I will use char until I get over about 64 characters. And then I'm going to ask, how close to 64 will I be? If almost everybody has about 64 characters in their name or whatever this field is, I'm going to use char. Can I predict its size? If I can predict its size fairly closely, use char, and I know its upper bound. Otherwise, I use varchar. The other thing is, if I go outside of a char field, like char 9, if I try to give him 10 digits for an SSN, I'm going to get an error. He won't accept it. On the other hand, if I try to give this person 17-digit name, it will simply chop it off and put in what it can. Other differences? Questions? So we have char and varchar. I'm going to talk about some others later. We have a whole chapter dedicated to data types. We have another constraint down here. Here's a constraint. This constraint is named null ename. Check ename is not null. Now I cannot use equal, not equal to on null. Why? Is your car newer than, older than, or the same age as my car if I don't have a car? The answer would be false, because nothing is a thing the same thing as no thing. Is no thing the same thing as no thing? The answer is always false if anytime you're working with null. So we use is and is not for null. More on that coming up later. Right now, I'm just trying to get through this. We'll take a break here in about 2 or 3 minutes. And so we have created the table employees. So we create table employees. This one only has 2 fields. I'm only doing it as soon as I say primary key. I say, what am I saying? I'm saying about ESSN. Cannot be null. 2 must be unique. The other constraint says check that it is not null. It's going to check that you have a name. You have to have a name to be in my database. If you don't have a name, I'm not going to let you in. But you don't have to have a unique name. They can be different. Okay. No comma at the end, usually a big problem with mistakes. Students will tend to make mistakes here. I'm going to ask you to write a couple of tables that are like this. Use this as an example. Do not use the same names. Do not just copy this and hand it in. I want you to change the names to make sense. I forget what I asked you to do, but something like that. Go. Go. Here's the word go. Go is not standard SQL. Go is not standard SQL. Go is unique to SQL Server. If you say go in some other language, it's going to give you an error because it doesn't know what it means. Go says, what Go does, it breaks it up into multiple programs. This is a batch program. So Go says, make everything above this happen. So stop, make everything happen, then start a new program and go until you get to the end of that one. When it hits another go, make that happen. Okay, the only time that this becomes really important is when you have create for now. When you create something, you say go before it, make all that stuff happen, then you create the table, then you say go at the end of it. Make it happen. If you don't, you will get some strange errors will pop up. You say, well, it worked once and now it doesn't work again, but sometimes it works and sometimes it doesn't. So notice that this is the create table, employees. I have go before it and go after it. You don't have to put go before and after all of your SQL statements. Only creates does it need to be there. It doesn't hurt to put it. Some students will be writing the select queries and they will say go and then they'll write problem 2 and then go and they'll write problem 3. That's fine. It doesn't hurt anything, but don't have to. So this is the create table. Go. How many dependents do we have? No, here's the way we do it in database. I don't know, 0 or more. What I'm going to do is, to get that, I have to bring in the idea of the foreign key. The foreign key, boom, is the primary key of the parent table. So I have a parent-child relationship. The parent is the employee. A parent has 0 or more dependents. In other words, one parent has many dependents, where many means 0 or more. It might not have any, might have 1 million. He's going to get in trouble with the IRS, but database-wise, I don't know how many they will have. The way we do that is, listen to this carefully, please, and make a note of it. The primary key of the one side, the primary key of the parent, gets copied into the child. The primary key of the parent gets copied into the child. And it becomes, here it is called a foreign key. The foreign key must be the same type as the primary key it references. So this foreign key takes me to the child's parent. Now with this setup, I can have as many children as I want. They all have a pointer to the parent in them. So the parent could be Joe, and he could have child Mary, Tom, and Sally, and Bill. They would all have a foreign key that took me to Joe's primary key. One parent. Okay. A foreign key, I'm going to say that usually the case, a foreign key keeps the same name as the primary key. Notice that this one, there's one of them in there that does not conform to that rule of, notice that DSSN, that's in the dependents table, D name, that's in the dependents table. Now here's one that doesn't conform. That one is special. That's a foreign key, and you can see that in the constraints. Okay. Now, what do I say about a foreign key? A foreign key, okay, here is the constraint that creates the foreign key. Constraint, and I usually put both of the table names in my constraint. I call this one dependents, employees, FK is the name. I don't worry about having a long constraint name. I typically don't like long names because I am a slow typist. But I don't mind a long constraint name because when I violate that constraint, I will see that constraint name come as part of the error message. Sometimes the error messages can get very cryptic, but I will see that name, dependents, employees, FK, as part of the error message, and I will know what I did wrong. If I don't have that name, then I just see an error 5601-22 at such and such a, that means nothing to me. References, so I say the foreign key. What's the foreign key? Try to get up on the board. ESSN is foreign key. What am I talking about? This one right here. ESSN in this table. References. Employees is the table, the parent table. ESSN. I like it when they have the same name. They do not have to have the same name. There's times when you cannot make them keep the same name, but I like it when they have the same name. Okay, one last thing, and then we're going to take a break. Go ahead.
What does the constraint do?
Okay, what does the constraint do? What does it mean? It means that when I put a child record in, the child record has a primary key, so I have to give it the primary key. The child can have anything it wants as a primary key as long as no other child has the same primary key. The foreign key, if you have a foreign key, then that value must be in the parent table. Listen carefully to what I said. If you have a foreign key, the value must be in the parent table. Did I say you had to have a parent? No. Can the foreign key be null? From a database perspective, yes. Now, do I want dependents with a null foreign key in my table? That's another question. That's what you want in your database. As far as database in general goes, you cannot have a null primary key, but a foreign key that is taking me from the child record to the parent record can be null. What do you think we call those records with a null foreign key? Orphans. Those are called orphan records. That's not a database error. Okay. Now, if you didn't have what I cannot have, and what it will check for, is I cannot have a child with a bogus parent. I cannot have a child with it will stop me from inserting a child record with a parent field that does not exist. Some textbooks will name that field the foreign key. Some textbooks will name this, child, and this one parent. I prefer to keep their names the same. Textbooks will vary on that. Okay. It's time to take a break. And so I'm gonna give you a break. I think today we had discussed changing our class meeting times. And I think today I'm gonna go ahead and end here. And we'll probably discuss that further later. So if it just doesn't work for you, I might come on in. I'll come in and meet with you. We're not going to have class on Monday, so okay. I'm going to pause the recording, and then we will move to lab at this time. The assignment that we're going to do is, well, let me go ahead and finish this up so I can go ahead and move you to lab. Notice some things about this, that there is no comma after the last entry. Everything else is separated by commas. This is a comment. Dash dash on a line is a comment that says the rest of this line, ignore it. It is best in SQL if you do not have a blank line. For example, a blank line is considered poor form. SQL Server will not have a problem with it. It'll just go right on past it. Some databases will get the hiccups. So I get students into the habit of putting something on every line inside of a statement. For example, this one doesn't matter. This blank line is fine. He's outside of the statement. But within this, I have no completely blank lines. SQL Server will not have a problem with it. Some students just insist on doing it. I try to get you not to put blank lines in there. SQL statements end with a semicolon. SQL Server will let you get away without it. I will put a little nastygram on it, a little, hey, you forgot your semicolon. And if you keep forgetting them, I'll take points off. But they will run just fine without them. Okay, let me go ahead and finish this up, and then I'll wrap up here in a few minutes. What does it say? What does it mean to be a foreign key? Child. Takes you to the parent. Do you have to have a parent? No. If you have a parent, if you have a value there, then what? You have the relationship, but if you have a parent, if you say, my parent is Joe, what has to be true about the parent table? Joe has to be there. Okay. So if my parent has SSN 2556, that parent has to be there. Which table has to get created first? The one, well, they both got primary keys, but the one with the parent primary key. The parent has to be created first, okay? And populated first. So that means you have to get the parents in there. We're not too populating them yet. We're just creating them. Which table, if I'm going to delete the tables, which table do I have to delete first? The child table has to be deleted first, because if I delete the parent table first, then all of those references in the child table, it will be a foreign key to nowhere. So when I deleted the foreign key, the child table must be deleted first. They're deleted in reverse order from their creation. Okay, let's go up to the delete. This is not standard SQL either. So this is not SQL. If I just say drop table dependents, it will give me an error. And I could say drop table dependents go, drop table employees go. That would run okay, but I would get 2 error messages, and I don't like error messages. This one suppresses the error messages. Notice line 11 up there. And this is the way it's done. Just go ahead, copy this, take a look, and we're going to be using it. If object ID, quote, dependence, close quote, close parentheses, is not null. In other words, if that table exists, then drop it. If the employees table exists, then drop it. This is not SQL. there is another programming language that is around it. And so those of you who have done a programming language, you know about if then else. Well, if then else is here, but we're not going to do if then else in this class. I lied, we just did. We're going to do this much of it. And in the next class, in the next course after this one, ITSE 2347, you get into the while loops and the if then else stuff and the logic of it and procedures and functions and all that stuff. This is SQL. Okay, this line 11 through 15 are not SQL. Well, they've got some SQL in them. Drop table is SQL, but the rest of it is an if statement. Okay, but we need it, so I'm going to go ahead and get it. I cannot create the database if I don't have these. So when I'm ready to test it. Now, one thing when you get ready to test if you execute, do not have something highlighted. Okay, don't highlight anything. If you have it highlighted and you say execute, it says execute. It says, I don't know what that is. That means you're trying to execute that part that you have highlighted. So don't have anything highlighted. So you say execute, and it will execute. Don't have anything. If you do, it'll try to highlight only what you have executed. You can execute just a single statement. If I said execute, I would execute only that part that I had highlighted. So I can just drop the tables, but I didn't create the tables. Okay. If I try to do it again, okay, execute. Now, suppose I try to again. Oh, by the way, if down here I have my output window. If I want to close that down, the command to do that is Control R, and it closes that command window. If that's important to you, I'll tell you that again. So if I try to create table employees, now I'm going to highlight that. What do you expect to happen? I already have a table named employees. When I try to create it, I'm going to get an error message. There is already an object named employees. Now, if I ran it and it executed that if then else, if it exists, then drop it, then it's going to run. So the nice thing about it is that I can execute it all multiple times. So if it's there, it drops it. And that's what you'll see if you look at the create AP SQL. You'll see that if it exists, drop it. And I just drop them all and then recreate them all. Questions? Okay, at this point, you should be able to make some sense out of the let's see what we've got in the way of the module 3. So you should be assignment 3. By the way, guided practice is in there. So I give you a problem that is like the one I'm asking you to do. And I say, go do this problem. So you do that problem. And then I give you my solution to it. Look at it and see what it's not graded. Don't ask you to turn it in. And then I give you the assignment. The assignment is just like that. So use that as a model. Our first programming assignment, I like you to fuss over your format of code. I'm fussy about my format, and I want you to try to get yours formatted nicely. Open a new SQL file. Okay, the file name. Pay attention to the file name. It is one thing about Canvas. I wrote this assignment before we had Canvas. Canvas will, if you resubmit, Canvas will mess with your file name. In other words, it'll put a 1 and a 2 and a 3. Don't worry about that. Some of this stuff I haven't covered yet. You'll have to get some of this, if you start working on this over the weekend, you'll have to get some of the stuff out of the book. Oh no, read the book. I'll cover it, but I just, pets, so let's see, we got pets and owners. A pet, here's the thing is, a pet has exactly one owner. An owner has 0 or more pets. Which one is the parent? Owner. Child is the pet. The child has a foreign key to the owner. Name your, I don't tell you what to name your fields. A field name does not have spaces in it. It is okay to have terse field names, meaning that just enough characters to let me figure out what it is. O name is fine. What is that? That's the owner's name. Okay, I got it. OID, owner's identification, owner's primary key. Terse names are okay, field names. We're going to see later that I can make the field name be anything I want it to when I print it for the user. So now I don't care what it is, as long SQL programmers tend to like short names that are unique. So I'm asking you to do two related tables, pets and owners. Appropriate lengths. How long is a person's name? 16 characters, 24 characters. 4 is too small, 256 too large. Okay. Do not zip your files, please. They're just text files, and zipping the file adds so much more work to it. The other thing is that make sure, for example, if this were your code, so if this were owners and this were pets, it would look a lot like this. I would expect to be able to just open it up, hit execute, give you 100. No, whatever the score is for it. No, I'm going to go through them pretty quickly. I'm going to look, then I'll look for, do you have this drop? Did you name your fields right? So remember, I specified here okay, notice that it's bold there. You will create 2 related tables, and I tell you what their names are. PETS, OWNERS. Okay. Please don't create pet and owner, because that would be something that we would get fussy about in database, because if the table names don't match, then I can't use them in another program. I'm going to have to go mess with my other programs that are using them. If this SQL file doesn't happen to match, that's not a big deal in SQL programming. Just change the name. But the name of that table is important. So I would get fussier about the name. I would fuss over common mistake, putting a comma after the last position. Common mistake, not having a semicolon. Common mistake is trying to create the dependence table, the child table before the parent table, or drop the parent table before the child table. Those are very common. It's tricky, but I'm going to let you guys, I'm going to let you take a break now. It's a little late, but we won't have class on Monday. I'll be talking to you more about the idea of changing our scheduling of the class. What I'm talking about doing is setting it to have a 2-hour lecture time on Wednesday, 2-hour lab on Monday. But we'll talk more about that. Okay, I'm pausing the recording. Zoom recording. Okay, I'm recording again. What I'm going to do, I'm going to test out that idea of Wednesday lecture, Monday lab. I'm going to hold the lab in this room. Okay, so I'll be here for lab. I'll hold the lab on Zoom, meaning I'm going to come in here, log into Zoom at 11 o'clock. If you stop coming to the physical lab, I will probably just go to all Zoom. So we'll see how you like it. And then if you want to come, if you're coming to the Monday lab, but I don't want to sit here by myself, because if everybody's on Zoom, I can do that from home. So we'll see how you guys want to work it. I'm not going to make you choose one way or the other. So you'll choose by what you do. Okay. Well, Monday is a holiday. Okay, so I'm not going to. Yeah, on Wednesday, a week from today, I'm going to do a 2-hour lab. Then the following Monday, I'll be here for lab at 11 o'clock, but I'm not going to have a lecture. Okay, so you may attend from home. I will be on Zoom. If you attend, you'll be able just to log in, talk to me. You'll need to have a way to do it. Now you can do it from your cell phone. You can talk from your cell phone. There's a way you can connect by phone. I'll send out that link. It works fairly well. We've tried it. Anybody on right now that's on from a cell phone? Scott, are you on from a cell phone? I saw your microphone click off there, I guess. I see some chat coming in here. Okay, your mic did not work. Okay. Joshua on the computer. Okay, well, you can do it from a cell phone. I'll look up that those directions and post them. It's a lot handier if you have a headset. Usually on if I'm doing just a straight lab, I will, and I'm not sharing the screen, I'll generally turn on my video, but you don't need to turn yours on. Okay. Let's see. Okay, I'm gonna end recording now. You have Amanda says. Yes, Amanda, that's true. But what I'm saying is that you can connect, if you don't have a microphone, you can connect and see on your PC. And then if you want to talk, you can connect with the cell phone. And you can talk on the cell phone and see on your computer at the same time. I see people saying they agree with me. So I guess somebody's done it. I never have. Okay, I'm gonna, the recording is in